This is AP Calculus BC, lesson 4-7.2, integration with partial fractions. So in 4-7.1, we just did partial fraction expansion, and now we're actually going to do the calculus. So today's date is Tuesday, April 21st, 2020. Our objective is simply to use partial fractions to take integrals. So when Taxman fails, you have two things that you can do. You can do integration by parts, which was 4-6, and you can do integration with partial fractions, which is 4-7. How do you know which one to do when you see this on the quiz and the test, right? So I guess it's really a self-check and a pre-test. But integration by parts is whenever things are being multiplied. So I'll say like it's kind of like doing reverse multiplication. And that's because it came from the reverse product rule, right? We took the integral of product rule, and that's how we derived integration by parts. And as a reminder of what integration by parts looks like, you have like the integral of u dv, and that's equal to u times v minus the integral of something like du is like v du or something like that. I had to think of it in my head as u dv and then use v du. Yep, that's right. Okay, I had to do the four quadrants, otherwise I'll forget. And then there's integration by partial fractions, which is what we're doing today, and that's what you're thinking of if you have some sort of it's not a good way to think about it in higher levels of math, but if you ever have some sort of quadratic in the denominator, I ran out of room, nator, or you just have a fraction for that matter. A fraction where the denominator has a higher degree than the numerator, and obviously Taxman has failed, that kind of indicates that you're going to be using partial fractions. And again, this really comes with practice. The reason that I am saying that doesn't apply to higher levels is because at really high levels, you just apply every tool in your toolbox, and until you've tried them all like 10 times each, then you really don't get the hang of it. So it's just one of those practice makes perfect things, unfortunately. So all today, though, is nice and easy stuff. So I say that, but it's still partial fractions. Here we go. How do we do this? We're going to set this thing equal to the integral of two fractions, fraction plus fraction. Let me go ahead and show you that it will fail really quickly. It's something that you don't need to do, but you will probably do it. You'll be like, okay, it's just an integral. Maybe Taxman will work. If so, you're off the hook, right? So Taxman needs a u. Taxman, I'm going to go ahead and erase all this when I'm done. U prime. My u is going to be, I'm going to choose the bottom, this x squared minus x minus 6. It's the most complex thing. That means Taxman is 3x plus 11. Take the derivative of this top to get u prime, and that's going to be 2x minus 1. And clearly, when I make that a fraction, Taxman fails. I can't pay Taxman a variable rate. Actually, that's a little room. I'm going to leave it there. So I'll just go ahead and say, right here, this fails. So how do we set this up? Well, luckily it's nice and easy, so it's just an a and a b, just some numbers. Sometimes at the higher levels there's like x's and weird rules that you'll have to memorize, but just for now it's just numbers. And the factors, how does this denominator factor? And you can do Ninja Star. I'm hoping you're at a level that you can do this in your head. What two numbers multiply to -6 and also add to -1? Well, 2 and 3, so -3 and +2, right? So if I do x minus 3 and x plus 2, then I have my setup, and I guess it's really two integrals here. So when I do my expansion now, I'm going to kind of ignore all this up here. I'm going to ignore the integrals and just do the expansion. So to do that, I think I have enough room to do it here. If I have 3x plus 11 on the left hand side and x squared minus x minus 6 on the denominator is equal to just this a x minus 3 plus b over x plus 2. I need to multiply a by x plus 2, x plus 2, x plus 2, x plus 2, and I need to multiply b by x minus 3 and x minus 3. What that does is it makes all of the denominators the same, and I can only look at our numerators. So our numerators look like this. It's now, I guess I should maybe box off this area. Our numerator now looks like this 3, wait, I want to use a different color instead. I now have this 3x plus 11, our numerator from the left, and I'm going to make that equal to the numerator on the right. Again, all of this is just one fraction now since I have like denominators. I'm kind of skipping a step, but I don't think we need to show it. And this is now a times the quantity of x plus 2 plus b times the quantity of x minus 3. So from here, we need to solve, and I can choose x to be whatever I want in order to make this come out nice. So let's try making one of these 0. Let's see what happens if x is equal to -2. If that's the case, then this term will be 0, and that whole thing is just gone. 0 times a is 0. Therefore, I just have the stuff on the left-hand side. So -2 gets plugged into this x. So 3 times -2 is -6. -6 plus 11 is 5. So I say 5 on the left-hand side. And then all this stuff, when I plug in -2, I get -2 minus 3 is -5. I get -5b. Oops. So this is equal to -5b. And therefore, b is equal to -1. Let's do the other side of that. What happens if x is equal to 3 to make that 0, right? So if x is equal to 3, the following equation happens. So this x is 3. 3 times 3 is 9. 9 plus 11 is 20. So on the left-hand side, I have 20. On the right-hand side, that's gone, and I just have 3 being plugged into this x. So 3 plus 2 is 5. So I can say 5a. And therefore, a is equal to 4. Okay, well, I have my expansion ready to go, so let me plug this all back in with integrals. We're running low on room, so let me try to conserve a bit of space. Whoop, whoop, whoop. Trying to make this all sectioned off here. So now I'm going to do, maybe I should label these with my steps too that I'm doing. So step 1 was checking that Taxman failed. Step 2 was realizing that I needed to use partial fractions, and then doing that partial fractions is step 3, and now step 4 is actually using the partial fractions that we found in order to solve. So my new problem is the integral of a, which is 4 over x minus 3, and then I'm going to add that with the other integral, b. I'm just rewriting this, but in place of b, we know that's a -1. So I have -1 over x plus 2, and I'm being super informal here. I should really have a dx and a dx. Especially since this year's lesson, I guess this year's doing BC and they're doing free response. Anyway, ignore that. How do I take the antiderivative of this? Again, you can use Taxman, but it's one of those things that I'm hoping that you can eventually see. This 4 can really be factored out in front, so let me rewrite this guy. This is the same thing as 4 times the integral of 1 over x minus 3 dx plus, I guess I should say minus, because that's a -1, right? So minus the integral of 1 over x plus 2 dx. And the only thing that is the antiderivative of 1 over something is natural log, because if you remember, the derivative of natural log of something, let's just choose x plus 1 for the sake of an example, that's equal to 1 over x plus 1, which looks awful familiar to what we have over here. So this was going forwards, taking the derivative. We're going backwards, so the answer here is 4 natural log of absolute value x minus 3. Why absolute value? Again, it's because natural log's domain cannot have any negative value, so we just do that to make sure that domain works out. And then we say minus the natural log of absolute value x plus 2 and absolute value, and don't forget your plus c, your cake. Cool, so there's our final answer. Box it. And let's try another. Example number 2. I will warn you guys, this one is harder. Why is it harder? There are fractions. A and b are going to be equal to a fraction instead of some nice little integer. So here we go. I'm not going to check that Taxman doesn't work, because this one I'm going to need all of this possible space. So I'm going to ignore the integral for a second. I'm skipping lots more steps now. I hope I'm not losing anyone. And I'm going to ignore this integral, so I'm just setting this fraction equal to some sort of a over, okay, I'm going to go ahead and factor this in my head. So what multiplies to 14? 1 and 14, no, 2 and 7. Oh yeah, 2 and 7 will somehow get 5. So if I do positive 7, so x plus 7, and if I do b, I'm giving room so I can multiply, x minus 2, -2 and plus 7 multiplied -14, and they add to 5, we're good. So if I add these two together, they should be the same. So let's go ahead and multiply. This is going to be multiplied by x minus 2 all over x minus 2, and this is going to be multiplied by x plus 7 all over x plus 7. When I multiply all of that, the denominators, all of these things are the same, so let's just set the numerators equal to one another. And I say 4 on the left hand side is equal to, on the right hand side, a times x minus 2 plus b times x plus 7. Cool, so let's choose nice values to work this out. And I know that I said this in my partial fraction expansion video last time, that this is one way of doing it, where I choose value like, what happens if x is 2? If x is equal to 2, then the following thing happens and this cancels out. You can do that, and that's the fastest way of doing it. The long way, I'll just mention, is using substitution or elimination, the skills that you learn from Algebra 1. And in the really advanced cases, you might need linear algebra, but that's a case for college level math. When x is equal to 2 on the left hand side is 4. This is always going to be 4. There's no x, so it's always going to be 4. And that's all gone. So if I plug in 2 to this x, 2 plus 7 is 9. So I'll get 9b. 9b. And as I warned, our answer is a fraction. Divide both sides by 9, and b is equal to 4/9. What happens if I do the other nice number? If I choose -7 to make this whole term 0, so if x is equal to -7, then on the left hand side I still have 4, so I'll copy that down. We still have 4, and then when I plug in -7 into this x, that's going to be -9a. -9a, divide both sides by -9, and a is equal to -4/9. Which is interesting. They're just opposites of one another. It's pretty cool. So what does this mean? Now it's time to take the integral, and we have plenty of room. I think I'm going to go straight down from here. So yes, if I'm following my work, step 1 was here, step 2 was here, and I'm going to go on to step number 3 now, which is actually doing the calculus. So I now have, my new problem is the integral of, I'm going to copy down this stuff, the a and b. So I have a, which is -4/9, so -4/9, and that's all divided by this x plus 7. So I'm going to do x plus 7, and this is just a cool little trick. You can do -4/9 like that, or even better yet, well, it doesn't really matter. I think I'm going to keep it really simple. You could do it like that, but let's just keep it as simple as possible. I don't want to confuse anyone. -4/7 all over x plus 7 dx, plus this other one, b is 4/9, so it's going to be 4/9 in the numerator, and then x minus 2 in the denominator dx. What does that look like? If I go ahead and just, again, kind of factor out any constant number, so it's going to be -4/7 times the integral of 1 over x plus 7 dx plus 4/9. Wait a second. Where's 4/7 coming from? I just realized that that is not correct. Oops. If you caught it, you guys can log it. I don't even know. I'll just have to trust you guys if you found it. It should be 4/9. 4/9 integral of 1 over x minus 2 dx. And just like we saw before, this is going to be the natural log. So I'm running out of room, so I'm going to go up here to the top right. So let's go right here. So this is going to be -4/9 natural log of this thing, x plus 7. So natural log absolute value of x plus 7, and then plus 4/9 natural log of absolute value x minus 2. And then don't forget our plus c. And that's our final answer. Box it. So it wasn't that much harder. It did have fractions, but I don't think those are too tricky. Will your answer always have natural logs in them? Pretty often, yes. I would say almost always, because the way that we set this up is we have a number over something with x in it, and you can always factor out that number, which means you'll almost always have a natural log. Very rarely will you not have a natural log. Okay, I know I've been speaking now for basically 15 minutes. That is the end of our lesson, so I'll see you guys tomorrow.